Welcome to PCM. My name is Billy, Product Line Director of Electrical Protection. So here today we are going to bring you our new and innovative silicon-based snubber products, which will have a very positive impact on how semiconductor devices place in the market, especially with increasing adoption of the silicon carbide. The switching speed is getting fast, which will bring many challenges such as voltage overshoot, unexpected oscillations, and EMC issues. Now, with our new technology, potentially those challenges can be addressed for both automotive and industry markets. So now let's look at our snubber bare die with a shape of either square or rectangle. From the assembling point of view, we optimized the surface metallization. The bottom side is compatible for both soldering and sintering, and the top side can be applied with wire bonding technology, example with aluminum bonding wire for the electric interconnection. So basically, we can say the overall assembly is compatible with state-of-the-art power module manufacturing process. So what is exciting is now we have the real power module examples to show our customers how to integrate the snubber into the power module and do the design. In our case, it's standard HBD power modules with 6-pack topologies, and each switch with 6 pieces of silicon carbide MOSFET in parallel. Now with 2 tiny snubber inside of power modules for each half bridge, we can significantly improve the performance and the switching behavior of the silicon carbide, allow it to switch much faster, therefore enormously reduce the power losses. According to the real test from the third-party authorities, the switching losses can be reduced up to 16%. In addition, the spike body is suppressed and the oscillation can be completely removed. On top of that, the EMC performance can also be improved. The typical application example is for the electric vehicle. In this case, the leakage current from the motor can also be minimized. So therefore, not only the efficiency from the traction inverter is increased, but also that from the motor. So definitely we can say the driving range of the electric vehicle is further extended. Now let's look at our dynamic demo of the snubber, which was actually designed by our expert here to visualize the basic function of our snubber. So now let's look at the effectiveness. The blue curve here shown here is the waveform without the snubber. You can see the spike voltage is very, very high, and at the same time, there's very strong oscillation here. And then if you look at the yellow curve shown here with our snubber solution, the spike voltage actually have been suppressed to a very low level, and the oscillation here is completely removed. And with our new technology, the silicon-based snubber, so we believe we can make the future power electronic devices operate more efficient and reliable. For more information, you can contact me at Melexis. Thank you for watching.